Okay, so everybody remembers thermoregulation, how we're talking about the different ways that animals keep their body in acceptable temperature ranges so they can function properly.
Yes.
Sophia, really?
Sorry.
Okay.
I just
They use a complex system of feedback mechanisms to help regulate some mammal body temperatures. That's an evolutionary. Doc, I'm sorry, but this music is kind of throwing off. Yeah, I'm not that tall.
Just hold on the.
No, put the little mute button on his keyboard.
Or just pause it.
Okay, the hard way works.
All right. My mojo's back. Here we go. So a complex system based on feedback mechanisms that help regulate some mammals' body temperatures.
What's so fun?
Moving on. The hypothalamus is a region of the brain between the thalamus and the midbrain, which are two different parts of the brain, that function as the main control center for the autonomic nervous system by regulating sleep cycles, body temperature, appetite. Those are all things that are natural that we can't control, kind of like a heartbeat. We don't control it, it's involuntary. And that acts as an endocrine gland by producing hormones, including the releasing factors that control the hormonal secretions of the pituitary gland. So that is a lot of words, and it's just mostly additional information that, if it helps you understand the topic of the hypothalamus, great. You don't have to memorize that. That wasn't even in the book. I just got it from outside.
No,
Yeah, we're gonna in our chapter read over it.
Okay, awesome, great. Okay, a group of nerve cells in the hypothalamus function as a thermostat in response to body temperatures when they deviate from normal range, and then it would the body would go into those previously talked about mechanisms, such as cooling down when you're too hot and shivering when you're too cold. Is everybody on the same page? Okay. Al, do you have a question? Okay. Warm receptors signal the hypothalamus thermostat when temperature increase, and at body temperature below the normal range, the thermostat inhibits heat loss mechanisms and activates heat-saving ones. I just basically explained that in a more layman term. And with some bacterial and viral infections, mammals and birds develop fever, which is just an elevated body temperature. Ectotherms, the lizard particularly exhibits the fever as well. And when ill, they seek warmer environments to keep their body temperature higher, which is a characteristic of an ectotherm. They use behavioral characteristics to put themselves in a condition where their body would be kept at a specific temperature, as opposed to us mammals and birds who are endotherms, and we use internal regulatory mechanisms. Do you want me to go over Kate's last two slides so you can just save it on? Do you want me to go tell them after I finish this?
I'll do it.
Was she on this slide?
I really couldn't tell you.
I don't remember those.
No, we already passed that. We already did that.
Okay. Yeah, I remember we did this because we talked about the energy cost. Okay, I think we ran activity and metabolic rate. Okay. Activity greatly affects metabolic rate in both. This is good. It ties into mine. In both ectotherms and endotherms. Maximum metabolic rates occur during a peak activity. I would imagine sprinting or something. The maximum metabolic rates occur during rate an animal can sustain is inversely proportional to the duration of the activity, so it's easier to keep a maximum rate for shorter periods of time. This kind of makes sense. You can jog for longer, but you're exerting less energy per unit of time, but you can sprint for a shorter time and still burn the same kind of energy.
Just tell me how.
Torpor and energy conversion. Apparently, torpor is a physiological state in which activity is low and metabolism decreases. Torpor enables animals to save energy while avoiding difficult and dangerous situations. Okay, that's interesting. So bats go into torpor during the day and feed at night. That makes sense. They would probably get eaten if they went during the day. And all endotherms that exhibit daily torpor are relatively small and thus when active have high metabolic rates and very high rates of energy consumption. I think I understand this. Does anybody have any questions? No? Okay. Al, what's torpor?
It's the metabolic rate.
Not particularly. And I just found out. Okay. And I know that. It's a
Yes.
Would you like me to pick up?
Yes, please.
Hello? Hello?
The phone system's not working. I tried calling down there.
Oh, I'm calling somebody. Sorry. Okay. Okay.
That's all I'm getting.
Wait, is torpor like when you're sleeping?
Yeah, do we do torpor?
No.
I don't know what that means.
Torpor is, okay, look at it this way. The animals that have extremely high metabolic rate, now, you know we've talked about, or you guys have talked about this, like very small animals, for example, the shrew. It has such a high metabolic rate.
A mouse?
It's not a mouse, it's not a rodent. It's smaller than a rodent, but they eat rodents. They eat insects, they're carnivores. Their metabolic rate is so high, they live out their entire life in 18 months, okay? But their metabolic rate is so high that they have to eat a considerable amount every 3 hours, or they run the risk of starving to death. But you have to understand, they're on a different time scale than we are. So they
year and a half?
yeah. But to them, that's a long life. I mean, you know, if you compare your lifespan to, let's say, that of a redwood tree would say that poor humans don't live very long.
That's true.
You know what I'm saying?
How long
It's
is
all
that?
relative. It's relative to your perception of time. So for the shrew, it's living a long life, but while with having such a high metabolic rate, while it's sleeping, to not run the risk of starving while it's sleeping, it goes into a state of torpor. So it will have very low metabolic process. It'll go into almost like a transient state, almost like a hibernation every night, or shall I say every day, because they're active at night. But so when they're sleeping, it's not like us. In us, it's not torpor. We're not trying to conserve energy while we sleep. But the animals that have to conserve the energy while they sleep, they go into torpor, which is this, it's almost like a hibernation state. It keeps them from starving to death. So, I hope, did I answer your question?
So do bears do torpor when they do like hibernate in the winter?
No, they hibernate. Hibernate means that they're sleeping through that whole
I think that's the
season.
next slide.
Yeah.
Everything is uploaded.
Thank you,
now.
Sam. Okay,
Thank you.
hibernation is a long-term torpor, Doc. That is an adaptation to winter cold and food scarcity.
Jacqueline, hang on 1 second. He's got a question. Go ahead.
So my brother has a pet bearded dragon, and it does like basically nothing all winter, but it does it like sleep all the time. That's called estivation, as far as I know, because it's not true hibernation. True hibernation is when they really go into this extremely low metabolic state. It's a little more intense than just simply estivation. Snakes typically go into estivation. I'm not sure, because torpor, from my understanding, is something that occurs on a daily basis, but that's something that if you want to research it right now and then just kind of get back to us on that, and let us know. Why don't you look up estivation and torpor and see what the difference is?
So when a mammal enters hibernation, its body temperature declines as its body thermostat is turned down. And every 2 weeks or so, the hibernating animal awakes and becomes active again, raising its body temperature. After this, the animal resumes hibernation.
Looks like you're gonna do that.
It's making me tired. Okay.
Raise the body temperature.
That makes sense though, because we talked about in my presentation how there's a specific range for every animal that of acceptable temperatures. So it's got to wake up every 2 weeks, keep it there. Makes sense. During hibernation, energy savings are huge and metabolic rates can be 20% lower than if the normal body temperature was maintained. As a result, animals can survive through winter on limited supplies of energy stored in the body tissues or as food cached in a burrow. Similarly,
Estivation.
okay, thought she meant to put estimation. Estivation, which is summer torpor, enables animals to survive long periods of high temperatures and scarce water. And then we go into mine, which we don't need to do again. Okay.
Good job, Julie.